Assalamualaikum and hi everyone. Today we start on chapter 2, Inequalities and Absolute Values. Chapter 2 consists of two subtopics, 2.1 Inequalities, 2.2 Absolute Values.
The learning outcome for this subtopic. The real numbers that we had learned from the previous lesson can be illustrated by using a number line. Every real number has a corresponding point on the line and called as a coordinate. Basically, the line is drawn horizontally. 0 is the middle value that divides the number line into two parts. Not all real numbers can be shown, so we generally show coordinates for integers only, where the right side of 0 are the positive integers and the left side are negative integers. The right hand direction representing the increasing value and the left hand direction representing the decreasing value. Because we can't list every single real number between any two numbers, so we use interval notation. The interval notation is written using the square bracket or round bracket. The square bracket, also known as closed bracket, and the round bracket, also called as open bracket. There are four types of inequality sign, which are less than or equals to, more than or equal to, less than, and more than. For the representation on number line, we use then circle to represent closed bracket and inequalities which have equal sign. And we use empty circle to represent an open bracket and the inequalities which have no equal sign. An interval is all the numbers between two given endpoints. There are three main ways to show intervals, which are interval notation, inequalities, and the number line. A closed interval is written with square bracket. Its inequality form is x greater or equals to 2 and less or equals to 6. This means that it includes both endpoints. To represent it on the number line, we must first draw the number line with the endpoints 2 and 6 in ascending order. Then, draw then circle at both endpoints and join them by a line. Meanwhile, an open interval is written with round bracket. The inequality has no equal sign, and the line has empty circles at both endpoints because it does not include the endpoints. The semi-open interval has two types. One is written with round bracket first and end with square bracket. And the other one is the other way around. For interval -3 to 5, the inequality is x greater than -3 and less or equals to 5. This means that -3 is excluded and 5 is included. So, the line has empty circle at -3 and then circle at 5. The interval -4 to 7 is the other way around. An infinite interval is an interval extending to either positive infinity or negative infinity. Because infinity is not a real number, so we always use open notation for the interval. For interval 3 to infinity, the inequality is x greater or equals to 3. This means 3 is included in this interval and it goes on until infinity. To represent it on the number line, we must first draw the line with endpoint 3, then draw then circle at 3 and join with a right arrow line. For interval -2 to infinity, the inequality is x greater than -2, which means -2 is not included, so the line has empty circle at -2. The next two examples are the other way around, where the line goes to the left. For interval -infinity to 2, where 2 is included, the inequality is x less or equals to 2. So, the line representation has a dense circle at 2 and joined with an arrow line going to the left. The next interval is -infinity to 0, but 0 is excluded. So, the line has empty circle at 0. And the last one is the interval negative infinity to infinity. In this case, the inequality form is written as x is the element of real numbers. This means that it is a set of all real numbers. The line representation is an arrow line extend to both sides. So here is the exercise. The question is, write the following sets in interval form, set notation, and represent it on a number line. Question A is, set of real numbers greater than or equal to 3. This means that the numbers start from 3 and it goes on until infinity. So the interval form is an infinite interval, 3 to infinity. And the inequality is x greater or equals to 3. But we want it to be expressed as set notation. So add the curly bracket. And the line representation is as follows. Question B is set of whole numbers between -1 and 5. Because of the word between, so we know that -1 and 5 are not included. Therefore, the interval is an open interval -1 to 5. However, we must define x as the element of whole numbers. In fact, the whole numbers included are 0, 1, 2, 3, and 4. But in set notation, we must write it with the curly bracket. To represent this on a number line, we must draw the number line with every point from -1 to 5. Then, draw the dense circles on the whole numbers from 0 until 4. So, there are two different ways to represent an interval on a number line. It depends on the classification of numbers. If the interval is defined for rational numbers or real numbers, then we draw circles and join with a line. If the interval is defined for natural numbers or whole numbers or integers, then we draw dense circles on every number included.
These are the learning outcome for this lesson. 2.1 Inequalities. Normally we have equal sign, but for inequalities the equation is no longer equal. Properties of inequalities. If A greater than B, then A plus C is greater than B plus C. Example, if 5 greater than 3, then 5 plus 7 greater than 3 plus 7, which is 12 greater than 10. Second properties, A times C greater than B times C for C greater than 0. Third properties, A times C less than B times C for C less than 0. And last one, if A greater than B, then 1 over A should be less than 1 over V. For A and B cannot be 0. Now we learn about linear inequalities. How to solve linear inequalities. Linear inequalities can be written as AX plus B greater than 0. AX plus B greater than or equal 0 or equal 0. AX plus B less than 0. And last one, AX plus B less than or equal 0. With A and B are real numbers and A cannot be 0. Example, solve the following inequalities. 2x minus 4 greater than 8. So for solving inequalities, x should be on left hand side and numbers move to right hand side. Then we have 2x greater than 12. Then 2 should be as division. 12 divided by 2, we have 6. So answer is x greater than 6. B, x minus 7 less than or equal 3x plus 5. The same thing, x move to the left hand side and numbers to the right hand side. X minus 3x less than or equal 5 plus 7. Then we have negative 2x less than or equal 12. Negative 2 divide. And by rules, multiply or division by negative number, sign must change. So sign less than or equal divided by negative 2 become greater or equal. Then 12 divided by negative 2, negative 6. Then we have answers x greater or equal negative 6. And then C, we have two inequalities in the same equation. Negative 7 less than 2 plus 3x less than 8. So 2 inequalities on the same questions. First, move numbers to both sides. Negative 7 minus 2 less than 3x less than 8 minus 2. Then simplify. Negative 9 less than 3x less than 6. And then 3 as division, both sides. So we have negative 9 over 3 less than x less than 6 over 3. Then simplify. Negative 3 less than x less than 2. So answer x is between negative 3 and 2. Last one is your exercise. Please submit the exercises at the end of lesson before the class ended. Thank you.